Today is lesson 3 in chapter 3, and it is all about direct variation. Before we get into today's lesson, though, I want to make sure we know things from before with proportional and rate of change, because we're going to be applying that information today to direct variation. So the first part says, on a graph, proportional means there is a straight line that goes through the origin. And remember, the origin is 0, 0. So on a graph, that's a straight line that goes through 0, 0. To determine if a table is proportional, we take y divided by x to see if all of the rates are equal. So that would be something like, if we have x, y, and I have 1 and 3 and 2 and 6 and 3 and 9. So we would take 3 divided by 1 and 6 divided by 2 and 9 divided by 3, and we would notice that when we simplify, they are all equal. If they are all equal to each other, the table is proportional. Next part is rate of change. Rate of change says on a graph, we can call the constant rate of change the slope. Okay? So when there is a constant rate of change, that is a slope. This would be an example of not having a constant rate of change if it's like that. There is no constant rate of change. There's a rate of change here, a different one here, and a different one here. So it is not constant, which means it's the same throughout. And we find the slope by looking at rise over run. If there is a constant rate of change, the graph will be a straight line. So this time, for our graph, it'll be a straight line. It just doesn't have to go through the origin. So that has a constant rate of change. This one was proportional because it was a straight line and went through 0, 0. This one is just a straight line. To determine if a table has a constant rate of change, we do the change in y over change in x. Remember, it's always y over x. It's just if we are finding the change, it is our change in y over change in x. To see if all of the rates are equal, if they are equal, the table has a constant rate of change. So again, if we're thinking of that same table up above, 2, 6, and 3, 9. As we think of this one, our changes, remember, on the outside it was plus 3, this one is a plus 1, and a plus 1. So if all of those come out to simplify to the same thing, then there is a constant rate of change. So don't forget, for proportional, it's the numbers in the table. For rate of change, it's the numbers of how it's changing on the table. It's also important that we remember there's multiple ways to talk about rate of change. We now know that rate of change, we solve it with change in y over change in x. That's the same thing as our rise over our run, which yesterday we talked about was our vertical change over our horizontal change. We know that's our slope. We know the variable for slope is m. We know the formula to find slope is y2 minus y1 over x2 minus x1, which is what gives us that change in our y values and our change in our x values. So that's the part that kind of gets confusing through this chapter, is we know so many things that all are talking about the exact same thing. They're just worded in slightly different ways. Okay? So as we're thinking about this, if things are proportional, what does that mean for constant rate of change? So since being proportional means there's a straight line through the origin, just like this. And constant rate of change means having a straight line, like this. We know if something is proportional, that means it also must have a constant rate of change. because here it is a straight line, so that means it's a constant rate of change. Since that straight line goes through the origin, that's why we know it's proportional. The only thing is it doesn't work the other way. Just because something is a straight line doesn't mean it will be proportional and go through 0, 0. So notice we have that disclaimer here. Does not work the other way around. Constant rate of change does not mean it's going to be proportional. It could be, but it doesn't mean it will be for sure. Okay? That was all review so far from the last 2 lessons. New part for today is a direct variation. So from before, we knew multiple ways of talking about rate of change. We learned all of these so far. Now we're talking a new way of discussing proportional. So if a relationship is a direct variation, it is proportional. That means anytime you see something that is proportional, it is a direct variation. If you see something that is not proportional, it is not a direct variation. Sometimes instead of saying direct variation, we say it varies directly. They mean the same thing. So if it says varies directly, it is proportional. If it does not vary directly, it is not proportional. And anytime it is proportional, meaning it's a direct variation, we can write the relationship in the form y equals mx. So that's going to be the equation that we'll use today when something is a direct variation or varies directly. So I have just an example down here. And this kind of talks through some of the review of what we've been saying. So if I have this table, if I look at my y over x, y over x, y over x, that's these, they all simplified to be the same thing, so that means this table is proportional. Remember, if it's proportional, that means there will be a constant rate of change. So just checking it here, my constant rate of change, my change in y was 3 when my change in x was 1. My change in y was 3, my change in x was 1. This is the one I gave above as the example. And anytime it is proportional, these two are going to be equal to each other. My y over x is equal to my change in y over change in x. So anytime it is proportional or a direct variation, these two things will be equal to each other. Then today, the new part is that if we know it's proportional, we can use this to write an equation for that relationship. So when we're looking at this, I know my slope or my rate of change is 3. So I can write my equation as y equals 3x. That means no matter what x value I want to solve for, I can find my y. If x is 4, 4 times 3 means my y would be 12. If x is 10, 10 times 3 means my y would be 30. In another case here, I have my tables, so y over x, y over x, y over x. When I do those and simplify, they are not the same. Remember, if y over x is not the same, it is not proportional, meaning it can't be a direct variation. So when we look, we know it's not going to be a straight line through the origin, but we can still check to see if there's a constant rate of change. In this one, my change in y was 2 and my change in x was 1. Same thing on the next one. So there is a constant rate of change. Since it's non-proportional, it means it won't go through the origin, but since there is a constant rate of change, it will be a straight line. And we do see that here. Straight line, it's just not through 0, 0. Since it is not proportional, these two things are not equal to each other because there is no constant unit rate when we do y over x. Just because there's one here doesn't mean it'll guarantee there's one on this side. Okay, just because there is a constant rate of change doesn't mean it will be proportional. If it is not proportional, it is not a direct variation, so we can't describe this relationship in an equation. Okay, so that's kind of the new part of today. your brain's feeling like it's a little overloaded, hopefully going through some examples will help you see it's not as much as you think. It's a lot of just reviewing within this lesson. So the first thing says, is the graph proportional? Yes, this graph is proportional, and you can tell because it's a straight line and it goes through 0, 0. So the next thing is, if it's proportional, is the relationship between the time worked and the amount of money a direct variation? And remember from the last page, we said it is a direct variation if it is proportional. So since it's proportional, yes, it is also a direct variation. So we're going to determine the amount that Robin earns per hour. We can look at the graph, we can look at this. Remember, we know that since it's proportional, I could do y over x, or I could do change in y over change in x, and still get my answer. They're going to be the exact same amount, no matter what. So I tend to like to just do y over x. So when I look at it, these are some of the points on the graph. Here was that 2:15, here was that 4:30. So let's try it. If we have y is 15 when x is 2, or we have y is 30 when x is 4, if we simplify both of those, 15 divided by 2, that's $7.50 per hour. 30 divided by 4, that's also $7.50 per hour. So we know Robin earns $7.50 for every hour that they work. Now it says write an equation to represent the relationship between the time worked and the money earned. Remember, we already said the equation will always be in this format. And we know what m is. We found it. Remember, because our m is the same thing as change in y over change in x, but in this specific case, our change in y over change in x is the same as y over x. So you could do it either way and get the same answer. So we know our m is going to be 750 because it's going to be the same thing as y over x. So that means our equation is y equals 7.5x. You could include the 0 there, but we technically don't need it as we write that equation. The next one says, after 2 minutes after a skydiver opens his parachute, he has descended 1,900 feet. So in 2 minutes, descend means we're going down. After 5 minutes, he descended 4,750. If the distance varies directly with the time, at what rate is the skydiver moving? So as we're going through this today, we're going to work on finding which one is our y and which one is our x. Sometimes it'll tell us, sometimes it won't. So as we go through, on the first couple I've underlined it for you, otherwise then we're going to underline it as we go. Whatever is before that varies directly is our y value. Whatever it's talking about directly after, that's our x value. We always want to know, does y vary directly with x, just like we always put y over x. So in this case, I know this is my y, this is my x. And since it says it varies directly, that means it is a direct variation, so it's proportional. So in order to do this, I can either do y over x or change in y or change in x. I can do it either way. When I look at this, we can do y over x, and I can do my negative number over that positive number. Make sure you're lining up the numbers correctly. Don't try to match this way. And I can test the other one too. Because it's proportional, we know it's proportional since it's a direct variation, we know that both of them are going to equal the same. Either way, when I do it, I get negative 950. And what that really means is negative 950 feet per minute. Don't forget, you could have done it the other way. The other way would have been change in y over change in x. And we could have looked at it and said, okay, how much did it change by? And remember, the easiest way to do that is take the second number minus the first number, and we would have found that it went down 2,850. Second number minus first number, it went up by 3. So if we would have done it this way, my change in y over my change in x, still when I simplify, it's still that negative 950. So once again, we're proving that when it says it varies directly, I can do it either way because that means it's proportional. When it's proportional, they'll both come out to be the same thing no matter what. Okay? From there, they want us to write an equation. Write an equation to represent the relationship between the distance and the time. Well, I know this is my rate, so it's going to be y equals negative 950x. Meaning, I can pick any amount of minutes and figure how far they would have descended in that amount of time. On the next one, it says a cyclist can ride 3 miles, I have it in the wrong spot, 3 miles in 0.25 hours. Assume that the distance biked in miles y varies directly with the time in x hours. So, varies directly, right before it is always my y, right after it is always my x. From there, we have to come up with our own second point. Well, we know it varies directly, so it's proportional. So, like, I could say that in half an hour, it would be 6. That means in 1 whole hour, it would be 12. So if you think of it, a quarter of an hour is 15 minutes. So every 15 minutes, I'm doing 3 more miles. So if we have 15 minutes plus another for 30 minutes plus another for 45 minutes plus another to get to our hour, that's our 12. If in 1 hour it's 12 miles, that also means in 2, that would be 24. We also know that if we have 0 hours, if we're given no time, we can't do any miles. We can't go anywhere because there's no time to go anywhere. Now that we have some of these points, we can graph. So I have 1, 12. I have 2, 24. I can do this one. It's a little bit more difficult, 0.253 and 0, 0. Usually we would use our straight edge, but I don't have one out right now. There's our line. Then it wants an equation. Well, for our equation, remember as we're finding our value, since it's a direct variation, that means it's proportional, so I can do it as either y over x or change in y over change in x. They're going to be the same thing. So as I'm doing this, I'm just going to do y over x, and that would be, pick any of the numbers. I'll just do 12 over 1. I could have done 24 over 2 or 3 over 0.25, and all of them would simplify to 12. So my equation is y equals 12x. That means the unit rate is the slope of the line, so the cyclist can ride 12 miles per hour. The next part says the grocery store sells 6 oranges for $2. Assume the cost of the oranges varies directly, this time it's not underlined, so varies directly with the number of oranges. That means the cost of the oranges will be our y, and right after it, the number of oranges will be our x. Fill in the table, the graph, and write an equation. So they told us that 6 oranges cost $2. That means I also would know that if I want to spend $1, half of that is $1, so half of that would be $3. I know I can use that same relationship because it is proportional. It varies directly, so they're all going to have that same pattern to them. Okay. The other thing we could say is if we have no money, we're not going to get any oranges. Once we have our table, we can fill in our graph. First of all, we know y is our cost, and I'm trying to write this kind of sideways, so sorry, it's not going to be the best. And x is our oranges. From there, I know I have 0, 0. If I end up buying 6 oranges, that's going to be $2. If I buy 3 oranges, that's going to be $1. And I know it's hard to see those lines there. They're kind of faded. And then we graph. Again, typically we would use a straight edge. I just don't have one out. So from there, since it is a direct variation, we know it is proportional. So I can do y over x or change in y over change in x. It doesn't matter. And again, to prove that, we can kind of look at both. Y over x would be 2 over 6. That is 1/3. If we do our change in y and change in x, well, that went down by 1, and this went down by 3. So change in y over change in x would be -1 over -3. Either way, that's still 1/3. So when it is a direct variation, these two things will be equal. You only have to solve it one of the ways, whichever way you prefer, whatever you think you're best at. From there, our equation would be y equals 1/3 x. Okay? The next part is now comparing them. So it's the same thing, but there's going to be more than one, and we're just going to compare them. So it says the distance y in miles covered by a rabbit in x hours can be represented by the equation 35x. The distance covered by a grizzly bear is shown on the graph. Which animal is faster? Now this one actually didn't say varies directly, but it did tell us which one was our y and which one was our x. Since we're comparing, we need to know what two things we're talking about. Well, we're talking about a rabbit and we're talking about a bear. They gave us some information already. We know that the rabbit has the equation of y equals 35x. That means we know our slope or our rate of change is 35. And since we're talking miles and hours, I know that's 35 miles per hour. For the bear, if I look at it, remember we're trying to compare these. So when we look at it, our slope here, and we can do slope by rise over run since it's a graph. My rise was 30, my run was 1. So 30 over 1 is 30 miles per hour. If it wants to know which one's faster, we look, is 35 miles per hour or 30 miles per hour faster? It's this one. So which animal is faster? We know the rabbit is faster. And it asked us to explain, we know that because 35 is greater than 30. Okay? The next one is comparing as well, but it's just a different situation, and they also give us a table instead of a graph. So it says Damon's earnings for 4 weeks from a part-time job are shown in the table. Assume that his earnings vary directly with the number of hours worked. He has another job offer, and they are willing to pay him $7.35 per hour worked. Which job has the better pay? So we're talking about two different things. We're talking about a new job, but we're also talking about the current job that he's working now. So they gave us some information. They said this other job, this new job, would be willing to pay $7.35 per hour. So we need to figure out what is our slope or what is our rate of change, because that's the same thing. We tend to talk about it slope as a graph, rate of change as a table. What is our rate of change for the current job? So again, because this varies directly, and we're talking about our y is our earnings and our number of hours is our x's, since it varies directly, we can figure that out since it's proportional, either doing y over x or change in y over change in x. So you could take this divided by this, or 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 we could figure out how it's changing. We don't have to do both because they're going to come out to be the same thing. So I would just pick two of my numbers, like here, do my y over my x. So that would be 90 over 12. And when I divide 90 by 12, I find that it's going to be $7.50 per hour. So when I go to compare these two, I look at it, and I say, which one has the better pay? Better means I'm getting more money. So my current job has the better pay. Okay, the current job pays more. We know $7.50 is higher than $7.35. These are the last types of problems that we have. And these are a little bit different than the other ones. Now we're actually going to, once we write our equation, so like in this one it could have been y equals 7.35x. This one could have been y equals 7.5x. This one could have been y equals 30x. Once we finally write our equations, we're actually going to use that equation to help us figure out a new amount. So it says, a 3-year-old dog is often considered to be 21 in human years. Assume that the equivalent age in human years, y, varies directly with its age as a dog, x. Remember, what comes before is our y, what comes after is our x. So write and solve a direct variation equation to find the human year age of a dog that is 6 years old. So first thing, we have to use the information we know to write a direct variation equation. So because it's a direct variation, we know it's proportional. So we can do y over x, or we could do change in y over change in x if we knew more than one point. Since we only know one set of information, our y and our x, we have to just do y over x. So my y is 21 years in human years, as it's 3 for dog years. We're not going to use this one because it's 21 human years when the dog is 3. That means my constant unit rate is going to be 7. So if it's 7, my equation is y equals 7x. Once I have my equation, what I'm going to do is I'm going to take that 6 years old and I'm going to plug it in. Since we're talking about that as the dog's age, that's x. If x is equal to 6, we would just say 7 times 6. 7 times 6 gives me 42 human years as our answer. So we're writing our equation, using that equation to solve something else. Okay? On the next one, it says a charter bus travels 210 miles in 3.5 hours. Assume the distance traveled is directly proportional to the time traveled. Write and solve a direct variation equation to find how far the bus will travel in 6 hours. On this question, we have y over x again. When we look at it, since it says it's directly proportional, sometimes they say that instead of varies directly. They mean the same thing. Direct variation, remember, means that it is proportional. So directly proportional means direct variation. So when I look at it, I know my distance traveled comes before, so that's my y, where my time comes after, so that's my x. So distance will be my y, that's 210. Over time, that's my x. When it's 210 miles, it's 3.5 hours. And when I simplify that, I get 60 over 1, or just 60. So my equation would be y equals 60x. That also means that when I go to solve, if I want to know for 6 hours, time was my x, so I plug that in. Y equals 60 times that x is going to be 6 in this problem. When I solve that, I find that that means it is 360 if I'm trying to find for 6 hours, how far do I go, and that's miles. So 360 miles in that 6 hours. The last one says the monarch butterfly can fly 93 miles in 15 hours. Assume the distance traveled is directly proportional to the time traveled. Write and solve a direct variation equation to find how far the monarch butterfly will travel in 24 hours. Once again, it says directly proportional. So that means the distance is going to be my y and the time is going to be my x. So as I look at it, my distance y over my time in x. And when I simplify, I do get a decimal, and that's okay. That just means it's going to be y equals 6.2x. I could write that as a fraction if I wanted in simplest form. From there, I want to know, instead of in 15 hours, what would it be in 24 hours? So I can use this and say, well, hours was my x. So instead of it being 15, if my x is 24, that would mean that I would end up with 148.8 miles traveled in that 24 hours, or within 1 day period. Okay? I know this lesson can be confusing, so if you have any questions, please let me know.